Number 8 says find the vertex. Guys, in a perfect world, you sit there and you go, oh, okay, I'm going to have 2x squared minus 8x equals -7 because I know I need to move the 7 to the other side because I'm trying to do complete and square. I pull a 2 out, I get x squared minus 4x. I'm going to add b over 2 or b over 2 squared to both sides, which is 4. But what I really added was 8 because of the 2 out front. So what I have is 2. I factor the left side, get x minus 2 quantity squared equals what would be a positive 1, meaning I have x minus 2 quantity squared minus 1 equals 0 or y. And therefore my vertex has to be 2, -1 because I flip the sign here and I keep this one. Now, why did I rush all the way through that? Because that's not how I would do this problem tomorrow. I would do this with your calculator. There's nothing wrong with the calculator if you're allowed to use it. By doing it in the calculator, I just mean we're going to graph it. 2x squared minus 8x plus 7, zoom 6. And really, of all our choices, only one of them even makes sense when we see what our minimum is, because our vertex is either a min or a max. In this case, it's a minimum. I'm thinking it's probably B because it looks like it's at 2, -1. Just in case tomorrow's is not so cut and clear, let's look at calculating it. We want to calculate a minimum, okay? And now I have to sandwich it in. I have to be to the left of that minimum. I'm to the left of it now. Really, I already was, but I got a little bit closer just to be safe. Press enter. Now I got to sandwich it in by going to the right side of it, okay? Enter, enter. And, of course, 2, -1. Never mind the 0.00000006. That is just our calculator's rounding error. It's 2, -1. Number 9, 10, 11, and 12 all work off the same function. It's given up above it in bold. So I'm going to just start off by graphing that because I want to know what it looks like for all of these problems. -2x squared plus 5x plus 3. I hit zoom 6. I'm about to answer a bunch of questions about this parabola. Thankfully, it's a nice one that fit on the page. Identify the maximum / minimum. Well, I can see that this one's a maximum, so I'm going to calculate it. Number 4 is our maximum, and we have to sandwich in that maximum. So you have to know what the maximum actually is. It's that top point. We want to be to the left of it. We press enter. Now we want to go to the right of it. So I arrow over. I'm to the right of it now. I press enter, enter. My maximum is 1.25, 6.125. We're going to need that going forward. 10 says identify the domain. Domain means all possible x values. Well, we learned with these parabolas, if we let this parabola go on forever and ever, yeah, it's going down forever, but it's also going out forever. It's going left forever and right forever. Well, left forever and right forever mean all real numbers, or negative infinity to positive infinity, okay? Number 11, identify the range. The range is the hard one. When you think range, think rangy. Okay, rangy with a y. It's all y values. And our parabola does not go up and down forever. It definitely goes down forever. These would be arrows down here, but it doesn't go up forever. It has a maximum point. So therefore, our y's are capped at that maximum point. That highest y value is 6.125. So our range is everything less than 6.125. It means all possible y values. Well, our y's can't go any higher than 6.25. We said that was the maximum. So you have to know that it's either 6.25 here or 6.25 here. It's definitely not D and it's definitely not A. And then you have to figure out the sign. Again, it was a maximum, so all of our y values were less than that maximum, meaning we need less than or equal to, I shouldn't say less than, I should say less than or equal to every time, that maximum. Now we're on to number 12 where we're going to find the zeros. That's a simple second calc. 0. We want to go to the left of this first 0. You do them one at a time. You do the zeros one at a time. We go to the left of it, which really means to go below it in this case. There's the bottom bun to our sandwich, and there's the top bun. We went left of it, right of it, press enter, enter. We get -0.5, 0. So that one's out, okay? That one's out. Really, they're all out except for B. But let's be safe, rather safe than sorry. Let's calculate that other 0, the one on the right. So we want to be to the left of it. There we are. We're above it to the left. Now we're below it to the right. Enter, enter. And 3, 0, indeed, it was B. as we thought. Number 13 gave people a lot of fits, okay, on all three classes because we only did this for one day. It was even or odds. Remember, we want neither of them. Odd and even means we are looking at the exponents. Okay? They have to all be odd exponents for it to even have a chance of being odd. They have to all be even exponents for it to have a chance of being even. Today, these are both odd exponents. These are all even exponents because that's a 1. These are all even. These are all odd. So the exponents kind of check out. We have to rely on one small little rule. Even functions can have constants. They can. So let's look back at our two things that could have been even. Even has a constant. That is an even function, meaning it's not our answer because we want neither. Even has a constant. Doesn't matter. That is definitely an even function. All the exponents are even. Odd plays by a slightly different rule that's harder to keep track of. Odd cannot have a constant. I shouldn't put constants. I should put constant, but all the same. That's what differentiates from option B and option D. Option D does not have a constant, which is making it an odd function. Option B has a constant, which means it's neither, because it looks like an odd function because of the exponents, but the constant causes it to not be an odd function. Odd functions can twirl around on the origin and land back on themselves. If we look at this crazy function, 6x raised to the 5th power minus 2x raised to the 3rd power plus x plus 3. It's going to be a crazy function because we've got a lot of different moving pieces in there, but it'll look pretty typical of a odd function. It's kind of got that S shape. Now, you look at that and say, oh, I can spin that around 180 degrees and it'll land on itself, but not if you spin it around the origin. If I spin this around the origin right here, this graph's going to move down to here. So really my graph's going to look like what I'm kind of tracing right here with my pencil or with my pointer. Okay? That's not landing on itself because what happened is it got shifted down to here. Therefore, it's our neither function. Even functions have to fold in half. Okay? Even functions have to fold in half. So it doesn't matter if they get shifted up or down, they still fold in half. Number 14, use the vertical motion formula given to you here. Write a function that represents the vertical motion described in the problem situation. It's a whole lot of hoopla. Okay? A rocket takes off. Here we get into the actual facts. A height of 25 feet. Okay? At an initial velocity of 315 feet per second. So one of those gets plugged in for V and one gets plugged in for H. And you know which one by what it's called. Height of 25 feet means that 25 has to get plugged in for H. Velocity of 315 feet means velocity has to get plugged in for V. Therefore, we have negative 16t squared plus 315, that's our velocity, t, plus our initial height of 25. Therefore, it's option C. Number 15 is just an uphill-downhill problem. We read our interval of increase and decrease from left to right, just like we would read a sentence or a paper, okay? So we want to know from left to right, which means x values, where's our graph increasing, where is it decreasing? Well, if I start here on the left edge, this is an arrow, so really it goes on for infinity to the left. As I start walking, I'm going uphill. And I stop going uphill right at 1.5 because that's my x value of this point. Okay? 1.5 is my x value, and that's where I stop going uphill. I turn around there and start going downhill, and I don't want the downhill. I want the increase. Okay? So from negative infinity on the left all the way until 1.5 is where I'm increasing. Guys, if I just had to take a gander, and I'm not sure about it because I haven't seen it just quite yet and looked at it, I'd say tomorrow's might be a decrease. So be able to answer the other half of this problem. Know what our interval of decrease is going to look like.